Yeah, so earlier we discussed how to calculate error N3, EN3, EN4, EN5. Yeah, so which is here. So here for error EN3 we had 0.044. Yeah, so and also for N the error from node N4 also contributes 0.044, and then N5 contributes 0.132. Yeah, so, and then we also mentioned that we can also put this in a matrix format. Yeah, so here you can see W7 here, W8 here, W9 here. So these are the weights here, the W7, W8, and W9. And then that's a 3x1, 3 rows and 1 column matrix. And here we have, so this cuts across 0.44, that is the error emanating from the output node, 0.44. And then that is E6. And then to get this output, it becomes W7 times E6, and that will give you this. And then W8 times EN6, that gives you this. And then W9 times EN6, would also give you the error. And that, yeah, so these are the errors. Yeah, so N3 contributes 0.44. N4, node N4 contributes N3 contributes 0.044, N4 contributes 0.044, and then N5 contributes 0.132 from this output error. Yeah, so the next thing will be to code this. Yeah, so let's go to our collab. And in our collab, remember we already have this output. So if I print this output, this would spit out the output from node N6. So you can see now that is 0.7. And remember our target is what? 1. So let's imagine that the correct answer should be 1. And then our output print is 0.71. So we can find the error at, so error at node 6 would be what? Remember, we did this earlier. Will be target minus this output. Target minus this output coming from, so target minus, put it here. So let's see, run this and print out the error at the spot. So we're actually printing the error at the spot. Yeah, we're printing the error at the spot. Error EN6, this should be EN6, not E6. And then, so let's print out the error here. And yeah, so we're printing, so this is the output from, from the output node. And then look at the error now. So this is the error. So what we did was to say 1 minus 0.6367, and that would give this one. So this is the error. And then, so now we've calculated this error. So we already have this error. So how do we calculate this? The errors here too. So we already have the error at the output node. So how do we also calculate the contributions of these nodes in respect to this output error? Yeah, so we had this formula earlier. Remember this one? We had this one. So we can also write it this way too. We can create a matrix multiplication. Remember, this times this would give you EN3. This times this would give you the error EN4 at node EN4. And then EN5, you will do N9 times this. That would give you the error at EN5. So how do we code this now? So what we want to do is to find error and let's see that again. N3, N4, and 5. So error at N3. So let me copy this one. Error at N3, error at N4, and error at N5. So we'll use our numpy to do the matrix multiplication. Remember we did this earlier, use the function. And then what we'll do is we can fetch. Remember, if you look at this clearly, if you look at our numpy, if you look at this stage 2 weights, remember we already had this one, stage 2 weights here. If you look at stage 2 weights, it reflects a 1/3 matrix. So if I'm here, so let me print out this one now, stage 2. So I can say, print this guy. So I can come here. So let me remove this one so that we know which of the printouts. So take this one out, and then I can come here before this matmore, come here and say, okay, well, our loan app. Yeah, remember this is the object loan print. So we can come here to say loan print. Print loan. Let's see that again. Loan print dot. So let's see this now. Let's see this one. You can see now. You see this, it's a 1/3 matrix. But if you look at what we have here now, we actually need, so this is actually W7, weight assigned to W7, which is 0.68. This is the weight assigned to W8, 0.207327. And lastly, W9 has got weight 0.59483. Yeah, you can see this is a 1/3, but we need a 3/1. So we need it in this format. 3 rows, 1 column, but here we have just 1 row, 3 columns. So what we can do now is to say, okay, well, we'll take it back here now. We have our matmore, and then we can take this one. So we say this matmore. I hope it works. Dot t. So it takes it from a 1/3 to 3/1. So comma, we multiply it by what? Multiply it by the output error. Remember, we already have the en6, which is this one, output error. And then that will give us the weights n3, an error n3, n4, and n6. So if I do this, I hope it works. So it works now. So let's print out this. So we have, let's print out this one. You can see now. So now we've calculated, we've solved for en3. So we can guess en3's value. You can see it has the error here now, 0.30844788. And then the value for en4 is 0.029. And then lastly, en5, it has this one. Yeah, so we've been able to code this one now. We've been able to code this bit. So we've been able to code this. The value here is at 0.44. We got that from what? From target minus the tag, the true value minus the output. So, and then based on this output error, we also find what en3 contributes to that error, which is 0.044. And then we also got what en4 contributes to that error, which is 0.044. And lastly, we've also calculated for en5. So en5 contributes 0.132 to that error. I hope this helps. Yeah, so thank you very much. See you in the next class.